En la frontera donde el viento del Sol se apaga y comienza el susurro del espacio interestelar, dos sondas infinitamente pequeñas siguen su curso midiendo olas invisibles y campos que se doblan como velos. Sus datos revelan que el borde no es un muro, sino una costura viva que respira, vibra y deja pasar noticias de un hogar lejano. Más allá del brillo de los planetas donde la familia del Sol se extiende en nubes de cometas y recuerdos gravitacionales, la palabra escape pierde nitidez. Esta es la historia de cómo Voyager avanza libre y sin embargo nunca del todo suelta dentro de un misterio que crece con cada kilómetro. The sun moves through a thin district of the galaxy, where gas dust and magnetic tension make a quiet weather that lasts for millions of years, and within this weather, the fate of a small craft becomes entangled with forces much larger than any machine. Astronomers call this district the local interstellar medium, and although it is so sparse that a stadium-sized volume holds fewer atoms than a teaspoon of air on Earth, it carries pressure, it holds a magnetic field, and it remembers ancient shocks from distant supernovae. The solar system does not sit still inside this environment. It drifts, it turns it, leans into the headwind of motion, and the solar wind that streams outward from the star meets that headwind and hollows a moving cavity whose shape changes with time. That cavity is the heliosphere, a bubble not of solid matter, but of influence anchored by plasma and magnetism, edged by balances rather than by walls. Within it planets circle and dust spirals, and the wind races faster than the speed at which pressure waves can travel until distance and resistance slow the wind heat it and wrinkle it into a sheath. Beyond that sheath lies the region where the interstellar medium with its own field and flow becomes the air of record. Voyager heads there with steady patience, a spark that keeps its course, while the ocean around it slowly changes the meaning of the word outside. In this ocean, the pressures add and subtract like shifting weather fronts. Thermal pressure from warm gas offers a soft push. Dynamic pressure from slow currents adds a directional shove, and magnetic pressure from a field that stretches across light years adds a tension that resists bending. The sun contributes its own pressure by way of the solar wind, a continuous outflow of charged particles that carry the solar magnetic field outward like threads in a moving cloth. Where outward wind meets inward medium, the balance draws boundaries with names that sound final, yet behave provisional. There is a termination shock where the wind slows from supersonic to subsonic flow, a heliosheath, where turbulence and draped field lines confuse direction, and a heliopause where the identity of the plasma changes and the density of electrons rises to interstellar values. None of these surfaces stay still. A strong solar outburst can send a pressure pulse that swells the bubble. A quiet season can let the cavity relax and thin. The sun marches through different patches of interstellar cloud, and the background field tilts or tightens, and the whole frontier inhales and exhales. Against this breathing edge, a craft that moves for decades becomes a needle that stitches a wandering seam. Instruments on Voyager translate scarcity into meaning. The plasma science instrument can taste ions when there are enough of them to sample yielding temperatures and speeds and densities. The magnetometer follows the local field like a compass that also measures the stiffness of the line it traces. The cosmic ray subsystem counts high-energy particles that come from the galaxy beyond, and high-energy particles born in the heliosphere, and watches their relative strengths trade places as the frontier nears. These streams of numbers assemble into a coastline map without rocks, and the map keeps revising itself as currents shift. A rise in the frequency of plasma waves can reveal a denser medium, Even when the direct plasma sensor sleeps, a sudden turn of field can signal a fold in the draping of lines rather than a new regime. Prolonged increases in galactic particle counts can argue that the shield of the heliosphere has thinned, yet even then the direction of the field can continue to align with the Sun, as if the old influence has reached a hand outward into the new domain. The ocean that waits the craft is not neutral to geometry. The interstellar magnetic field does not point in a way that flatters a diagram, but slants across the path and warps under the pressure of the solar wind. In places, the two fields reconnect, breaking and rejoining to open channels for charged particles. A reconnection far from the craft can let cosmic rays pour along newly aligned routes and raise the counts on Voyager without any obvious change in the measured field direction at the probe. A compression in the heliosheath can stall the outward motion of the frontier temporarily, so that the craft, which moves at many kilometers per second, appears to linger near a threshold that slides away. A shock launched from the inner heliosphere can ring the interstellar medium like a distant bell, and months later Voyager can hear that ringing as plasma waves, whose pitch gives the electron density. Thus the outside speaks, but it speaks in echoes that carry the memory of inside events, and the message about location becomes tangled with the memory of origin. Scale turns confidence into humility. The probe races faster than any aircraft, and yet takes years to cover a distance that the solar wind crosses in months. The Sun itself moves at tens of kilometers per second relative to its surroundings, pulling the bubble into a shape more like a long tear than a sphere with a compressed nose and a drawn-out tail. The craft does not approach a static shore. It approaches a shore that drifts and ripples. A crossing reported on one day can be complicated by a reversal of particle gradients on another day, and the neat word beyond has to make room for a boundary that folds back on itself. To speak of escape in such a place requires choosing a frame. If escape means outrunning the gravity of the Sun, then speed and energy decide the matter, and the craft has won that contest. If escape means leaving the solar wind domain, then the measure lives in pressure balances and field topology that breathe. If escape means no longer belonging to the family of the Sun, then gravity re-enters with a quiet veto. Because the Oort cloud extends for trillions of kilometers and remains bound, and the star will carry that cometary halo along its galactic path for ages, and the craft will move within that far family even when the wind bubble is a memory. The first step of the narrative therefore arrives as a paradox. The probe reaches an outside that moves with the inside, and it carries a signal that decays with power even as the medium grows richer in density and field. It leaves a wind and enters a weather. It leaves a shield and enters a sieve. It leaves a map and enters a draft of a map written in pencil. The local interstellar medium surrounds the heliosphere and shapes it. The heliosphere shelters the planets and sheds particles back into the medium, and together they create a layered place where belonging is a gradient rather than a switch. Voyager proceeds steady in motion, patient in listening, and every measurement that declares a threshold also carries a question mark. What appears as an edge becomes conversation, and the conversation never quite ends because the ocean and the island travel together. The heliosphere begins as an act of breath from the star and continues as a negotiation with the medium that surrounds it, a bubble that owes its existence to motion, heat, and magnetic tension rather than to any wall that a traveller could touch. The solar wind, a stream of charged particles launched from the hot outer atmosphere of the Sun, rushes outward in all directions, carrying frozen in magnetic fields that turn the emptiness into a vast moving fabric. Close to the star, the wind is fast and orderly, and pressure waves cannot catch up to it, so disturbances run behind like ripples on a river. Farther out, the weight of the interstellar environment pushes back. density grows with distance as the wind expands and weakens, and where the outward pressure can no longer outrun the sound speed of its own plasma, a boundary forms that engineers name the termination shock. There, the flow slows from supersonic to subsonic conditions, energy is traded for heat, and particles born neutral in the surrounding medium slip into the wind as pick-up ions, adding a faint chemical accent that reveals the exchange between inside and outside. Beyond the shock lies the helios sheath, a thick, restless region, where compression, turbulence, and draped magnetic fields tangle into an unruly weather. In this sheath, the wind does not simply stream outward. It slides curls and reconnects as magnetic field lines break and join under stress. Every reconnection opens a door for particles to travel along new pathways so that direction itself becomes a conditional statement. The helios sheath is not a uniform ring. Pressure is higher toward the nose of the heliosphere where the sun's motion meets the oncoming flow of the local interstellar medium, and lower toward the tail where the bubble is drawn out into a long wake that the solar wind continues to feed. Seasonal changes on the sun, measured in years rather than months, also reach outward because a stronger solar cycle launches a more forceful wind, and pressure pulses travel into the sheath like migrating storms. When one of those shocks passes a point in space, the local magnetic field tightens and the plasma heats, and the effect lingers long after the shock itself has moved on, so that Voyager's recordings trace not a fixed landscape but a field of memories. The outermost layer of this bubble is the heliopause, which is less a shell than a shifting compromise where the identity of the plasma on one side differs from the identity on the other. Inside, most electrons and ions have their origin in the sun's wind, and their density and temperature carry that signature. Outside, the electrons belong to the interstellar medium, and the density is set by the environment between the stars. The transition can be steep in some properties and gentle in others, which is why the word edge misleads. When the cosmic ray counters on a craft register a sustained rise in high-energy particles that come from the galaxy, it suggests a thinning of heliospheric shielding. When the magnetometer shows that the direction of the local magnetic field has rotated only slightly, it suggests that the field lines at that point are still shaped by solar influence. When a radio-like sensor hears the ringing of plasma waves at a frequency that betrays a higher electron density, it argues for interstellar conditions even if other instruments are not in perfect agreement. The heliopause therefore behaves as a sieve that sorts particles by energy and by pitch angle, more than as a wall that forces a binary choice and that sieve flexes with time. The pressures that sculpt this bubble come in several kinds that add like chords. There is thermal pressure from the heat of the plasma, dynamic pressure from bulk motion, and magnetic pressure from the strength of the field. The interstellar medium contributes all three. The local field has a preferred direction that does not match the solar equator, and as the wind pushes outward, it drapes that field around the bubble, creating a laminar cloak in some places and a wrinkled curtain in others. Where streamlines converge near the nose field lines can become taut, and the plasma can stagnate. Where they separate near the flanks, the flow can ease and allow entryways for cosmic rays to wander inward. Voyager's path intersects this cloak at a particular angle, rather than at a perpendicular strike, so its measurements reflect a geometry that no single diagram can universalize. This is why crossings repeat in the numbers as if the probe were stepping across several fine threads, rather than one thick rope. Each thread marks a change in one property, and the weave sets the stage for the next shift. The scale of the whole structure forces patience. Even at many kilometers per second, a craft needs years to traverse the sheath, while the sun can dispatch a strong outburst that crosses the same distance in months. Thus, the sheath keeps receiving new weather from the inside while the craft continues to move, and any attempt to draw a clean border must account for this constant superposition of old and new disturbances. The nose and the tail differ not only in shape but in memory. The tail holds relics of older solar winds stretched thin and stirred by Kelvin Helmholtz, like instabilities where flows shear past one another, while the nose remembers the most recent battles between outward wind and incoming medium. If the Sun enters a region of slightly higher interstellar density, or a patch where the magnetic field is stiffer, the entire bubble responds, shrinking and brightening toward the nose and thickening its sheath as pressure builds. And if the Sun moves into a clearer patch, the bubble relaxes and the sheath thins, and the craft that once stood near a threshold may find itself well inside again without changing course. To understand why escape is a moving target, one must hold all these layers in mind together. When a probe leaves the supersonic wind, it has not left the bubble. When it enters the sheath, it has not yet entered the medium between the stars. Even when the electron density proves interstellar magnetic topology, may still retain the geometry of a solar influence, because field lines wander and reconnect on scales larger than the path of a single traveller. The heliosphere is therefore best pictured not as a boundary stone, but as a breathing skin pressed by the galaxy outside and nourished by the star within, always rebuilding itself as it moves through space. Voyager proceeds through this skin with equanimity, counting particles, reading lines, and converting faint whispers into meaning. And every new measurement that suggests a neat crossing also proposes a fresh complication, as if the bubble insists on being known only in verbs rather than in nouns, in the acts of flowing, bending and ringing that never pause long enough to become a fixed place. Once, in a rare span of centuries, the outer planets arrange themselves along a gentle arc that lets a single spacecraft fall from one to the next, and borrow speed at every meeting, and in the final years of the 1970s, that chance arrived and reshaped what leaving the solar system could mean. Engineers at the Jet Propulsion Laboratory studied this geometry and saw that Jupiter, Saturn, Uranus and Neptune would stand so that a craft could dive through their realms, change direction at each close pass, and carry away a dividend of motion without spending more fuel. They called the sequence a grand tour, but behind the title lay a calculation as precise as the inner workings of a clock, a cadence of planetary orbits that repeats only every few human lifetimes, a resonance of opportunities that would not return for roughly 175 years. The alignment offered passage not only outward but outward with purpose, because the gravity of each giant can both deflect and accelerate, turning the massive field of a planet into a slingshot that trades path for speed. At Jupiter, the first craft could dive through the deep well of the largest planet, sweep past a moonlit system, and exit with a new heading and an added handful of kilometers per second. At Saturn, a second turn could aim the traveller even higher over the plane where the planets circle. At Uranus and Neptune, if the path were chosen correctly, the craft could skim cloud tops, ride unseen highways between rings and moons, and then depart on a course that would never return to the Sun. Choices made in this window were not merely navigational but philosophical. Voyager 1 took a path that placed the Saturn-Moon Titan at center stage, a decision that favored the study of a thick atmosphere over the continuation of the grand tour to the farthest planets, because the turn required by a close Titan flyby would bend the course steeply out of the ecliptic and trade future visits for present science. Voyager 2 accepted the longer road following Jupiter and Saturn, with later passages by Uranus and Neptune, and in doing so it stitched the first and only human thread through all four giants. The geometry of these choices demonstrates a lesson at the core of escape. Every speed gain arrives with a direction cost, and every direction earned determines what horizons will never be seen again. Gravity assists conserve energy overall. They move it between the spacecraft and a planet in ways that on planetary scales are minute, but on a craft scale are life-changing. From the viewpoint of the Sun, a craft can leave with enough energy to climb forever, yet the conditions that made that energy possible depend on an arrangement that itself is temporary, a fleeting gate built by the slow dance of worlds. The launch dates within the late summer of 1977 were calculated to catch this gate, and to meet Jupiter when the planet would be in the right place to hand off the traveller to Saturn in a chain. The time between these encounters, measured in years, allowed instruments to gather context, to chart radiation belts, to trace magnetosphere boundaries, and to calibrate for the dust and plasma that fill a realm far beyond the asteroid belt. The data served not only to explain the planets, but also to refine the art of surfing gravitational seas. By the time each Voyager left the last giant, it would visit the figures describing its path were already the first lines of an interstellar trajectory, because after the last turn there would be no more massive wells to redefine the course. When a slingshot sends a craft outward, it changes the craft's velocity relative to the Sun, and that altered energy can be enough to surpass the threshold that defines solar escape in the classical sense. Yet the aftermath is not a clean severing. The same calculations that make the alignment possible also measure the Sun's hold through distant reservoirs like the Oort cloud, a cometary cavern so large that light requires months to cross even inner portions and years to cross the outer depths. In this context, the Grand Tour acts as a delivery mechanism, not to the outside of the solar system, but to its far frontier where belonging becomes a gradient rather than a binary. The elegance of the alignment hides a further paradox. A slingshot increases speed at the cost of entangling the spacecraft with the orbital motion and rotation of the assisting planet, so that the path that follows bears the imprint of local conditions at every encounter. The ecliptic tilt, the latitude of closest approach, the timing relative to magnetic storms all become small signatures that persist as the craft enters the domain where solar wind shapes become dominant, and later where interstellar pressures push back. Even decades later, when Voyager listens to plasma waves in the interstellar medium, its sensors are carried by a bus whose attitude control thermal behavior and radio geometry were constrained by the demands of the long planetary arc that came before. The alignment also revealed the character of escape as a social act among fields and bodies. Jupiter's gravity not only flung each craft onward, but also exposed it to belts of radiation that tested electronics and altered instrument duty cycles. Saturn's rings imposed navigational clearance that shaped approach distances, and thus the vector of the next outbound leg. Uranus and Neptune added their own magnetic tilts and unexpected winds nudging orientation plans and power budgets. Every gift carried a trace of obligation, and those obligations lasted long enough to influence the craft's performance when the frontier of the heliosphere finally came into view. When engineers speak of once-in-a-lifetime windows, they admit that the solar system itself enforces a cadence on ambition. The same cadence that opened a path also set a law of scarcity on repetition. If the alignment is a gate, then it is a gate woven by time, and stranger still, the gate transports not only a machine, but also the meaning of outside that the machine will later interrogate. The choices made in that window determined that the craft would approach the heliosphere nose rather than tail, that it would cross draped fields at specific angles, that it would hear the ringing of interstellar plasma, with antennas aligned by design constraints inherited from distant moons and rings. Thus the story of the boundary begins long before the boundary, and the escape that follows carries the fingerprints of every encounter that made it possible. The rare alignment is not a backdrop. It is the first cause of a path whose later mysteries are inseparable from its early steps, a reminder that in a gravitational system leaving is always a sequence of trades, and each trade saves a question for the road. Gravity Assist operates as a meeting between a swift visitor and a massive host, and in that meeting the visitor leaves with a new path and a changed speed, while the host yields an imperceptible slice of its own motion. The craft falls toward a planet, curves around it, and climbs away. In the planet's frame it arrives fast and departs fast with nearly the same magnitude, but in the frame of the Sun the story changes because the planet itself races along its orbit. Add the planet's motion to the departing craft and the vector sum becomes a new speed that can exceed what the launch vehicle alone could ever provide. The turn is not magic, it is geometry. The closer the craft passes to the center of mass without striking atmosphere or rings or trapped dust, the greater the angle by which its path can bend, and the greater the difference between the incoming and outgoing direction measured far from the planet. The bend converts direction into energy in the solar frame, and the prices paid in the slightest change to the planet's orbit a change too small to trace. At Jupiter, the deep gravity well allows the strongest change. The spacecraft drops toward a world that holds most of the planetary mass of the system, dives through a magnetosphere so large that it paints radio auroras across its poles, and races past moons whose plumes and Tori feed ions into space. It leaves with a heading altered by many tens of degrees and a speed relative to the Sun increased by several kilometers per second. That added speed is not conjured from nowhere. It comes from Jupiter's own motion around the Sun, a transfer so minute on the planetary side that it vanishes into the noise of precision yet decisive for the tiny machine. At Saturn, the craft repeats the exchange with a different aim. A flyby that favors Titan trades the continuation of the Grand Tour for a steeper climb out of the plane, where the planets orbit, and that choice sets a destiny for every later encounter with the heliosphere. All along the turns must respect limits that are as practical as they are physical. No pass can be so low that heating radiation or ring debris threaten the vehicle. No turn can ask the spacecraft to point its high-gain antenna away from Earth for long, because the link to the deep space network is its only lifeline. Course corrections are planned with thrusters that sip propellant reserved for decades, so every meter per second of adjustment must be earned by a gain in science or safety. The giants therefore act both as gifts and as gatekeepers, granting speed while narrowing the corridor through which future options will run. What matters for escape is not the speed near the planet, but the speed far away once the planet's pull fades to a whisper. In that far field, the quantity that decides fate is the craft's total energy relative to the Sun. If the energy is negative, the craft is bound and will crest at a far distance, before sliding inward again on a grand ellipse. If the energy is exactly balanced, the craft would coast forever while slowing without ever quite stopping a mathematical edge case. If the energy is positive, the path becomes open, and the distance to the Sun can grow without limit. Thanks to the chain of meetings with the giants, the Voyagers reach positive energy and continue outward forever. In that precise sense they have escaped, yet the word drifts when it leaves the page and meets the sky. The same craft that holds positive energy remains a citizen of the solar system's gravitational address for a very long time, because the Oort cloud stretches for trillions of kilometers and its faint members still circle the Sun. Within that sphere, the Sun's gravity, though thin, still ties the space to the star, and the craft moves within that domain for ages. In addition, the system itself moves through the local interstellar medium. The Sun carries its bubble into a headwind of gas and magnetic field, and the craft's outward speed must be compared not only to the Sun, but also to that larger flow. In some directions, the background wind adds, in others it subtracts, so the meeting with the frontier depends as much on angle as on magnitude. The slingshots thus deliver more than speed. They deliver orientation. At Jupiter, the turn fixes a longitude of approach to the heliosphere's nose. At Saturn, the chosen path sets a latitude that determines how the craft will slice through draped magnetic fields near the boundary. Those angles decide which portions of the turbulent sheath the craft will traverse, which folds and ribbons of field it will sample, which channels of cosmic rays will open or close along the way. The gift of speed therefore writes the questions the probe will be able to ask. The cost of that gift keeps appearing in the spacecraft's body. Close passes through radiation belts teach caution in scheduling sensitive instruments. Power must be hoarded because the radioisotope generator fades a little each year, and warmth is a scarce commodity in the deep cold. The path that gave energy also demanded hardware margins, and those margins guide operations at the frontier, sometimes dimming a sensor to preserve a heater, sometimes pausing a long observation to protect a memory register that once survived a storm near a giant planet. Even the meaning of velocity carries a tie. Speeds quoted in the solar frame are large, but the Sun itself circles the galaxy, and the local cloud moves with respect to the Sun. The spacecraft approaches the heliopause with a skewed encounter rather than a straight collision, and the magnetic geometry there privileges motion along certain lines over others. Charged particles will slide along those lines, and the craft will read their gradients as if they were winds, yet those winds are shaped by the direction it inherited from ancient turns. In the end, the slingshots and the speed they granted do not simply cut bonds. They reveal which bonds never yield. The spacecraft cannot choose a new grand path now. It travels the lane fixed by meetings long past. It cannot ignore the gravitational family it departs. It moves through its far members for a span beyond any mission plan. It cannot pretend the interstellar medium is a blank calm. It meets a flow that cares about angle, about field direction, about the subtle twist printed into its trajectory by Jupiter and by Saturn. Escape in this light becomes not a door that swings once, but a series of thresholds negotiated with grace, each one bought by a trade whose terms echo all the way to the edge. Every voyage into a thin and turbulent realm depends on senses tuned to whispers, and the twin spacecraft carry instruments that turn scarcity into maps, time into context, and faint counts into the outline of a frontier that refuses to stay still. The plasma science instrument measures the speed, temperature, and density of charged particles in the solar wind by sampling their arrival directions and energies, reading the flow as it slows, warms, and thickens with distance. On Voyager 1, this sensor fell silent in the early years, which forced density to be inferred indirectly later on, while on Voyager 2 it continued to report the breath of the wind as the sheath gathered around the bubble. The magnetometer reads the local magnetic field as a vector and as a strength, letting field lines become pathways in the mind so that a slow rotation hints at draping, rather than at a clean break, and a sudden tightening signals a compression that may have ridden outward from an inner eruption long months before. The cosmic ray subsystem counts high-energy particles that arrive from the galaxy at large, and those born within the heliosphere, and as those two families trade dominance, the device watches the system switch from shield to sieve from an inside, where heliospheric particles crowd the channel, to an outside where galactic particles flow more freely, and their gradients flatten. the low-energy charge particles instrument listens to the middle ground, where particles carry the memory of local processes more than of distant sources, and by tracing their pitch angles relative to the field, the instrument learns whether transport happens across lines or along them, a subtlety that matters when the boundary sorts motion by geometry. The plasma wave subsystem reads electrical vibrations in the surrounding gas, and when shocks launched by solar storms ring the medium like a struck bell, its antenna hears the tone. Because the frequency of those waves depends on electron density, a rising pitch reveals a denser environment, and thus a step toward interstellar conditions, even when a direct taste of the plasma is missing. Cameras, photopolarimeters, and spectrometers did their deep work in the days of the giant planets, but their legacy lives in the calibration and health of the bus that now carries the radio, because an image system once needed steady pointing and careful thermal control, and the same steadiness now keeps the high-gain antenna locked to Earth across a span so large that each command climbs for many hours before it arrives. The power for all of this comes from generators that convert heat from slowly decaying radioisotopes into electricity, and that gentle decline forces a choreography of duty cycles, heater choices, and instrument schedules. Warmth becomes a kind of fuel, and every watt saved on a quiet sensor can keep a valve or a gyroscope alive when the cold deepens. Communication runs through the deep space network with its great dishes in widely spread longitudes that catch a signal weakened into a whisper, and in that whisper, the timing and framing of bits carry not only measurements, but also the story of the spacecraft's body, because voltages, temperatures, and attitudes are their own weather that can color what an instrument thinks it sees. The transformation from telemetry to knowledge begins with careful subtraction. Background counts from the bus electronic noise from the readout chain, and known artifacts born of past radiation storms are removed, so that a rise in particle rate can be trusted as a change in space rather than a fever in the thermometer. The counts then become distributions in energy and angle, and those distributions become temperatures, speeds, and directions, by way of models tested closer to the Sun, where the flows are stronger and the statistics are kinder. The field measurements undergo their own alchemy. Short runs average to beat down the jitter of turbulence, long runs map slow rotations that tell of folding and draping, and sudden spikes become flags that a compression has arrived from within, carrying the memory of an old eruption across a volume measured in billions of kilometers. From these steps, a composite emerges that no single instrument could supply. Particle gradients reveal a change in shielding field alignments. Confess a geometry that still remembers the Sun, and plasma wave tones declare a density that belongs to the space between the stars. The instruments also test one another, and that cross-examination breeds caution that deepens the mystery rather than dissolving it. When cosmic ray counts rise, yet the field direction hardly changes, the interpretation leans toward channels opened by reconnection rather than a full departure. But when the plasma wave pitch climbs and stays high, the claim strengthens that the surrounding electrons are no longer the wind's own. When low-energy particles fade while high-energy particles grow, the sieve has tightened its mesh, and still the magnetometer may show that the texture of the mesh is woven with solar threads carried outward on old lines. The bodies that carry these senses are not passive. Attitude control thrusters correct tiny wobbles that would scatter particle arrival angles and confuse the pitch angle distributions. Heaters shield delicate electronics from a cold that would shift baselines and masquerade as new physics. Memory managers pace the recording and playback to fit a data rate that shrinks as distance grows. Little by little, the instruments surrender some of their former reach to preserve the core of the listening, and that triage is itself part of the science, because the order of priorities encodes what the frontier most demands to be known. From this orchestra of narrow throats and faithful ears rises a picture that is fluid by nature. The heliosheath appears as a foam of compressed flows rather than a smooth lane. The heliopause behaves more like a braided river that sorts stones by size than like a cliff, and the interstellar medium just beyond proves to be restless, ringing, in answer to shocks that were born under a distant sun. In that restlessness, the meaning of escape bends by instruments that do not agree all at once by a density that proclaims outside, while a field direction whispers inside by a particle rain that thickens as if a door had opened while the hinges still creak with familiar rhythm. The very need to listen across so many channels and to reconcile their statements without forcing a verdict becomes the reason the edge resists a single name, and the reason the word beyond continues to mean a place that the craft enters by degrees rather than by a single step. The termination shock waits like a muted surf line far from the sun, a place where a fast thin wind meets accumulated resistance and must yield by slowing, heating and thickening, and the path to this frontier reveals why a shock in plasma is both a mechanical and a magnetic event. The solar wind begins near the hot outer atmosphere, with speeds of hundreds of kilometers per second, carrying outward the solar magnetic field, frozen into the moving plasma like filaments within a glass stream. As it expands into the growing volume of space, the wind cools and its density falls, yet its bulk speed remains high enough that pressure waves cannot travel upstream to warn the flow of obstacles. That is what supersonic means in a plasma sense, not a sound heard by ears, but a limit on the communication of compression. The interstellar medium pushes back with its own pressures, part thermal, part magnetic, part dynamic, from the relative motion between the sun and the local cloud. At some distance, the wind no longer outruns the speed of its own pressure waves, and a discontinuity forms that converts directed energy into heat. Across this termination shock, the wind falls from supersonic to subsonic, a change that marks not a sudden stop but a change of conversation in the medium, because downstream of the shock information about pressure can move in all directions, and the flow must navigate by negotiation rather than by blind rush. Voyager 1 reached this shock in the middle years of the first decade of the new century, and Voyager 2 crossed it later, and the two crossings together showed that the shock is not a sphere but a dented, wrinkled, time-dependent surface. The positions differed by many billions of kilometers, and by years of solar activity, so the shock had moved, pressed inward during a weaker wind, and pushed outward during stronger seasons. Measurements at the shock read like a ledger of exchanges. The flow speed drops, the temperature rises, and low-energy ions that once rode with the wind now share their energy with a population of pickup ions created when neutral atoms from the interstellar medium drift inward, become ionized by sunlight or by charge exchange, and are captured by the wind's magnetic field. These pickup ions, already moving relative to the wind when they join, carry a broad energy distribution and absorb much of the shock's energy increase, which warms the downstream region in a way that is not evenly shared among all particles. The magnetometer sees the magnetic field tighten and rotate modestly, evidence that the frozen-in field has been compressed and that the geometry of the draped lines is shifting under stress. The plasma wave subsystem hears enhanced wave activity, the hiss and ring of a disturbed environment, and those waves help scatter particles, adding to the mixing that defines the heliosheath just beyond. The cosmic ray subsystem records a subtle but sustained rise in the scatter of particle directions, as if the path between regions has sprouted new side doors, and low-energy particles that once flowed outward in organized streams are now guided by a maze of tangled lines. The shock does not look the same to every energy. high-energy particles can cross back and forth, sampling both sides, as they drift along magnetic gradients, while the bulk plasma must stay with the flow. In this layered crossing, the idea of a single boundary softens. There are precursors upstream where waves and energetic particles announce the coming change. There are overshoots and undershoots in the fluid variables within the thickness of the shock itself. There are downstream relaxations where temperatures and field strength settle toward their sheath values. Voyager's path samples one cut through that complexity, and even within that cut the values breathe as solar transients arrive. A shock launched years earlier by a coronal mass ejection can cross the termination region and strengthen or weaken the standing shock, and the probe then measures a local version of a global event, turning a far solar eruption into a close change in the frontier. The dynamic nature of the termination shock matters for the meaning of escape, because it sets the initial conditions of the heliosheath journey. Downstream of the shock, the subsonic plasma can be deflected by pressure gradients and by magnetic curvature forces. It no longer streams straight outward, but slides around the nose toward the flanks and the tail, pooling in places where geometry and pressure conspire. A craft moving through this region measures speeds that are no longer simply radial. It sees transverse components, vortices and layers where properties change over distances too short for a simple model to predict. The shock also seeds the population of anomalous cosmic rays, particles born as neutral atoms far upstream that become pickup ions, are accelerated at or near the shock by diffusive processes, and then roam the sheath and beyond with energies high enough to test the sorting power of the heliopause. Their behavior becomes a tracer of the boundary to come, and yet their source sits in the very process that marks the end of the supersonic wind. The termination shock thus operates as both a gate and a factory, admitting the traveller to a new regime while manufacturing the conditions that will complicate all later measurements. Geometry enriches the story further. Because the interstellar magnetic field approaches at a slant, the shock's distance depends on direction. Toward the nose, where the headwind presses, the shock lies closer to the sun. Toward the tail it recedes. At intermediate longitudes, draping and reconnection can shape the surface into bulges and dimples that a single trajectory cannot map but can only hint at through sequences of changes. Voyager 2, which kept its plasma instrument alive, saw a sharper, more textbook shift in density and temperature, while Voyager 1 relied on indirect measures and on the chorus of waves to infer the passage. The difference is instructive rather than contradictory. It shows that even the idea of crossing holds meanings tied to instrument sensitivities and to the sky's mood at the moment of arrival. Above all, the termination shock introduces the traveller to a rule that will persist all the way to interstellar space. Each boundary carries memory. The sheath remembers the shock that fed it. The heliopause remembers the sheath that presses upon it. The interstellar medium beyond remembers the shocks that travel through it, from a sun that the craft has left in position but not in influence. When the word escape is spoken in the presence of such memory, it loses its illusion of finality and becomes a statement about which processes dominate here and now. Voyager moves on from the termination shock into the heliosheath, with a new context written into its instruments and recorded in its counts, and the shock falls behind not as a line on a map, but as the beginning of a sentence that will still be read at the next threshold and the next. The heliosheath receives the slowed wind from the termination shock and turns it into a restless weather, where flow, heat and magnetic tension trade influence from moment to moment, and a traveller learns quickly that progress here is measured not in distance alone but in how the properties of the medium refuse to hold still, long enough to define a rule. The subsonic plasma no longer bears a single dominant direction. It spreads curls and slides toward the flanks as pressure gradients and curved magnetic lines guide it around the nose of the bubble, and that sideways drift means that a craft flying outward can sample streams whose local motion is neither purely radial nor steady. The ratio of thermal pressure to magnetic pressure rises and falls across short spans, so that in one interval the field stiffens the flow like a spine, and in the next the heat slackens that control and turbulence blooms. Reconnection. The breaking and rejoining of field lines under stress occurs in patches that create magnetic islands and flux ropes, and those structures trap and release particles in bursts that leave signatures in low energy counts and in brief rotations of the local field. Voyager passes through some of these ropes as if crossing soft boundaries stitched into the sheath, and each crossing resembles a minor version of the larger thresholds to come a shift in particle direction distributions, a sudden tightening of the measured field, a change in the pitch of plasma waves as density pockets drift by. The sheath inherits memory from the shock and gathers new memories from the sun. Pressure pulses launched by solar eruptions far inside continue to move outward, and when they reach the sheath they compress it, heat it, and sharpen its draped field into tighter folds so that counts and fields seen by the craft vary on timescales set not by its own motion but by weather launched years earlier. The draping of the interstellar magnetic field around the bubble, forced by the outward wind into a cloak that lies along the boundary, also wavers with global geometry, making lanes where particles can stream along lines more easily than they can cross them. In such a setting, diffusion becomes directional. High-energy particles favor sliding along the field, and their gradients flatten as those lanes open, while low-energy particles struggle to cross and show sharper boundaries where the mesh resists. Kelvin-Helmholtz, like shears, may appear where flows slip past one another along the flanks, rolling up the interface into vortices that feed turbulence deeper into the sheath, and Rayleigh-Taylor-like effects may contribute where pressure stratification supports waves on the draped surface. None of these names are felt by the craft as labels. They are felt as variations that rework the expected order of measurements so that a day of rising galactic particle counts may be followed by a day of partial retreat when a compression passes, and a smooth rotation in the field may be interrupted by a burst of small reversals that signal a chain of connected islands drifting through the path. Charge exchange between fast ions in the wind and slow neutral atoms from the interstellar medium produces energetic neutral atoms that run free of the magnetic field and carry away momentum, cooling the plasma in places and altering the balance of pressures in ways that feed back on the flow. Those same energetic neutral atoms born in the sheath and beyond can later be imaged from near Earth by instruments that detect their arrival directions and energies, and while Voyager cannot see them directly in that way, it moves through the regions that give rise to the distant images, providing ground truth for a map made of particles that ignore the very lines that direct so much else. The sheath is thick, measured in tens of billions of kilometers along some directions, yet structured on scales far smaller, so that a spacecraft's record becomes a tapestry of fine threads and models that treat the region as a smooth layer struggle to capture the day-to-day choreography that the sensors hear. In some stretches, the field points almost parallel to the expected solar spiral, as if the old influence lingers. In others, it leans more toward the interstellar orientation, as if the outside has found a way inward along the folds. Plasma waves hum at pitches that rise and fall with density pockets, and the pitch sometimes climbs to values that hint that interstellar electrons are already mixing into the sheath, complicating the question of where the next border truly begins. The concept of a stagnation region, a volume near the nose where flows slow and densities increase, before the ultimate transition is supported in the numbers by intervals where the measured speed of the plasma drops, the inferred compression grows, and the field tightens without a decisive rotation. And in those intervals the cosmic ray gradients change more in magnitude than in direction, as if the sieve has narrowed its mesh without yet altering its weave. Voyager's path through this churn is not a line across a chart, but a dialogue with a medium that edits the questions as quickly as they are asked. When the craft encounters a sector boundary carried outward from the inner heliosphere where the magnetic field polarity reverses relative to the Sun, the local field can flip sign while preserving its general direction, and the flip can bring changes in particle pitch angle distributions that mimic a boundary crossing if read without context. When a global co-rotating interaction region born where fast and slow wind streams pile into one another in the inner heliosphere reaches the sheath, it can introduce a patterned sequence of compressions and rarefactions that rewrite the baseline of counts for weeks, and only by tracing the cadence can the event be identified as a traveller from inside, rather than a permanent feature of the sheath itself. In such a place, the very idea of plotting distance to the heliopause as a simple function of time falters, because the frontier can advance or retreat over spans comparable to the distance the craft covers in a season. The meaning of approach must therefore be defined statistically by trends in density, inferred from wave tones by sustained increases in galactic particle fluxes, by the decline and flattening of heliospheric particle gradients, and by the slow drift of the field toward orientations more at home in the interstellar medium. Even then the sheath refuses a single narrative. It is at once a buffer that absorbs and transforms energy from inside a reactor, that creates new particle populations through pickup and acceleration, and a lens that shapes the paths by which cosmic rays find their way inward. Voyager moves through this volume like a pen scratching across a living page, and the lines it draws show the outline of a boundary made of many small boundaries, each alive, each able to pass over the craft like a wave, so that escape becomes a matter of surviving and understanding a long conversation, rather than stepping through a door. In the Helios Heath, the data declare and then immediately qualify the models, predict and then revise, and the traveller learns that the way to the outside is a braid of roots in a foam that never holds its shape. The heliopause enters the story as a promise of outside, yet when a traveller arrives, the promise frays into a gradient where one property declares a clean change, while another clings to familiar alignment, and the result is an edge that refuses to behave like a line. The classical picture suggests that the boundary marks the place where plasma born of the Sun yields to plasma that belongs to the interstellar medium, and that suggestion holds when a radio-like ear hears the pitch of plasma waves rise to values that imply a higher electron density than any found in the helios sheath, a density consistent with the thin gas between the stars. In such moments the medium speaks in tones that place the craft beyond the solar wind's final breath. Yet the magnetometer often reports that the local magnetic field rotates only modestly across intervals that otherwise look interstellar in density, and this small rotation strains the expectation that the field outside should point along a different, stiffer direction set by the local interstellar magnetic field. Instead, the field seems draped and smoothed, its orientation changing by degrees rather than by a sweep, as if lines that once threaded the solar wind still frame the space just beyond the sheath. At the same time, the cosmic ray counters register a permanent rise in galactic particles and a decline in heliospheric ones, with gradients flattening as though a shield has thinned into a membrane and then into a veil. These mixed signals tempt a clean verdict but then pull it back, because they reveal a frontier that sorts by species by energy and by pitch angle, not by geography alone. Consider the flow of low-energy ions that once rode outward with the wind. Near the threshold they fade, replaced in count rate and direction by high-energy galactic particles whose paths respect magnetic lines more than they respect the nominal position of a surface. The sieve tightens for some and opens for others, and reconnection between draped solar lines and interstellar lines can open windows in one region, while curtains hang tight in a neighbouring patch. A small rotation of the field can therefore coexist with a large change in particle streaming, and a large rotation can in other moments coexist with little change if the transport routes have reshaped themselves in the background. The craft senses these differences not all at once, but as a succession of fine steps that look like miniature crossings, each with its own signature, so that an engineer can name several precursors, several departures and several returns over a span of distance that in a simpler fluid would have hosted a single border. Intervals arise that behave like a stagnation layer on the inside where subsonic flows slow, and densities rise and field lines align with the draped geometry of the skin, and then follow intervals where the electron density matches interstellar values, while the field preserves a remembered direction, and then follow quiet stretches where all indicators settle, as if the traveller has finally cleared the influence. Even then, shocks born at the sun continue to arrive, their pressure pulses ringing the medium and briefly modifying the local tone in ways that echo inside conditions across a gap that was meant to divide. The fact that radio emissions tied to remote plasma waves can be heard beyond the heliopause means that the outside carries the memory of the inside, and that memory reaches the probe with a time delay, so that even a measurement used to prove a new regime speaks with an accent from the old. Geometry strengthens the ambiguity because the approach is oblique. The local interstellar magnetic field leans across the nose rather than striking cleanly, so the draping effect creates a layered sheath of lines that lie nearly parallel to the surface for a long way, and the craft cuts those layers at a shallow angle. A shallow cut turns a narrow wall into a corridor of rooms, and a set of short rotations into a long drawn-out drift that an instrument experiences as a near constancy. In such a corridor, diffusion becomes anisotropic easier along lines than across them, and the counting devices register this preference as a change in the way gradients decay. The idea of a porous heliopause follows naturally from this picture. The boundary allows energetic particles from the galaxy to thread inward along connected lines, while confining the lower energy population that depends on crossfield transport. Charge exchange with neutral atoms continues to occur on both sides, creating energetic neutral atoms that pass through the magnetic barriers and carry away signatures of both environments. The result is a slow hydraulic balance that evolves with time, a tide at the threshold that can raise or lower the effective barrier, not by moving a shell, but by retuning the mesh. For the navigation of meaning, the modest rotation of the magnetic field matters most, because it argues that the vocabulary of inside and outside needs an extra term that admits that origin and current allegiance differ. A particle can be born under the sun and spend its current life following a line embedded in interstellar flow. A field line can begin as a solar spiral and end as a strand within a draped curtain. A density can reach interstellar norms while the texture of the field still shows solar weave. The spacecraft lives in that extra term for months and years, and its data turn the heliopause from a noun into a verb. The boundary does not sit. It drapes, reconnects, sifts and rings. When a pressure pulse arrives from inside the field, tightens and the local tone climbs, and for a time the craft stands nearer to the inside in behaviour even while numbered distance continues to grow. When the pulse passes, the field relaxes and the density returns to the interstellar value, and the same spot resumes its claim to being beyond. The message for the question of escape is simple and demanding. If escape means crossing a place where one set of properties yields to another, then the craft has escaped many times and will continue to escape with every new surge or lull. If escape means settling into a regime where every instrument agrees that a new domain has been reached, then the craft must live with a boundary that stages a slow unfolding, where consensus takes the form of trends rather than steps. Voyager keeps moving and measuring, and the heliopause remains not a fence but a living seam, an edge that does not edge. Teaching that outside is a function of what one asks and how long one listens. Magnetic geometry turns the frontier into a set of choices written in lines rather than in walls, and Voyager learns to read those lines as if they were currents in a dark sea that accept some travelers and deny others, bending paths, trapping particles, and shaping what escape can mean. Near the sun, the magnetic field rides outward with the wind in a spiral pattern, set by the rotation of the star, a spiral that twists more with distance and gradually weakens, yet carries a memory of polarity that flips with the solar cycle and sends great sectors of one sign and then the other into the outer reaches. Far from the sun, the local interstellar magnetic field has its own direction, set by the larger galactic neighborhood and by past shocks that swept through the gas long before the spacecraft launched. At the heliospheric boundary, these two families of lines do not meet politely. The outward spiral drapes around the nose of the bubble, thinning into a sheath that lies almost tangent to the surface, while the interstellar field leans across at a slant, presses and partially threads the cloak. In places the lines break and rejoin, a process known as reconnection, and each reconnection stitches a portal that allows particles to move from one side to the other along freshly linked routes. Where the draping is smooth, the field behaves like a laminar skin that prefers motion along itself rather than across. Where the draping wrinkles into folds, magnetic islands form, and those islands act as temporary cages that mirror charged particles back and forth until scattering sets them free. The magnetometer on Voyager reads these features as modest rotations and sudden tightening signatures that look small in angle, but large in consequence, because even a few degrees can switch the ease with which cosmic rays can slide inward along lines. The cosmic ray subsystem sees the result as changes in the slope of particle gradients and in the balance between arrival directions, and the pattern is often more telling than the absolute level. A day of flattened gradient and broadened pitch angle distribution hints that a gate has opened somewhere along a folded line. A day of steep gradient hints that the mesh has tightened and that transport across the field has grown more difficult. The draped cloak does not lie perfectly flat. Global flows push it into ridges near the nose, while shear along the flanks swirls it into rolled edges, and each feature supports its own microclimate of particle motion. Magnetic tension acts like an elastic fabric that resists bending and tries to smooth sharp kinks, while pressure from heated plasma tries to swell pockets outward, and the two influences find temporary peace in shapes that survive for days or weeks before new arrivals from the sun alter the balance. Sector boundaries where the magnetic polarity reverses sail outward and cross the sheath like invisible curtains, and when one drifts by the spacecraft, the local field can flip while maintaining the same general direction, a reminder that topology matters as much as orientation. On such days, low-energy particles that depended on previous pitch angles may find themselves mirrored or lost, and high-energy particles less sensitive to small twists continue almost unbothered, producing an apparent disagreement between sensors that when read carefully tells a coherent story about how the boundary selects by energy and by angle. The idea of a magnetic wall appears in some intervals as the field strength rises and resists penetration by low-energy particles, and Voyager's counters record a temporary reduction in inward streaming at certain angles, yet even this wall leaks where reconnection threads have opened. Ringing from distant shocks generates waves that scatter particles in pitch angle, blurring the difference between a long and a cross transport, and for a time the magnetic wall turns into a magnetic fog. The picture gains a second dimension when the tail is considered. Behind the sun the draped lines stretch into a long wake, and islands born near the nose can be advected into that tail, so that a craft which has already crossed a density threshold may still move through field textures that remember their solar origin. This lag in magnetic texture explains why electron densities can look interstellar, while field directions remain reluctant to rotate fully, and why the word beyond keeps bending to the question asked. Particles that are tied to lines by their charge, including many of the cosmic rays that Voyager counts, respond to the field as to rails laid through the medium, while neutral atoms ignore the lines entirely and carry momentum across them, creating a quiet exchange that steadily alters pressure and thus the shape of the field itself. A boundary that includes neutrals acquires a schedule that is different from a boundary ruled by charged particles alone, and the mismatch of schedules becomes another ingredient that moves properties out of step. The spacecraft, a single point in a vast and changing weave, lives by statistics. It averages field measurements to see slow rotations, then zooms in to watch short-lived kinks. It folds daily particle counts into trends, then examines brief bursts that signal the passing of a flux rope. From these nested views emerges a rule of magnetic life at the edge direction is destiny. A small change in the angle between the local field and the preferred route of galactic cosmic rays can widen a channel or narrow. It can let particles from a distant supernova stream in more freely, or keep them at bay, and the craft will read that fate long before a density meter or a speed estimate announces a classical transition. This rule feeds back into the meaning of escape. If escape means to move into a region where the sun's field no longer controls particle motion, then escape is a function not only of distance, but also of the degree to which draped lines still guide the medium. If escape means to enter a corridor where the interstellar field sets the terms, then the question becomes how many reconnection threads have already sewn the cloak to the outside. The answer changes with time, with the arrival of sector boundaries, with the fatigue and recovery of magnetic tension, and with every pulse that comes from the inner heliosphere like a slow heartbeat. Voyager moves through this network of lines with patient attention, and the field that bends continues to turn precise directions into a broader truth. There is no single outside, only a geometry that decides which travellers are free today, and which must wait for the next fold to open. When the sun throws a great outburst, the shock that swells from that bright violence travels outward for months, crossing orbits, leaving a trail of compressed plasma and tightened magnetic field, and when it finally reaches the distant frontier, the darkness answers with a soundless ring that instruments can hear as waves in the charged gas. These waves are not sound in the human sense, but electrical oscillations of electrons swaying against their own inertia, and their natural pitch depends on how many electrons fill a given volume. A sparse medium sings at a low pitch, a denser medium at a higher one. The plasma wave subsystem on Voyager is a patient ear for this mute choir. When a shock born under the sun arrives, the instrument hears a rise in pitch that reveals the local electron density, and by following those changes the craft can map the medium without tasting it directly. This method became crucial when one spacecraft lost the ability to sample the basic plasma flow for the waves continued to speak, even when the cup that once sipped the wind fell quiet. The first time an interstellar pitch rang across the recorder, it arrived not as a single note, but as a rising tone that swept upward over days, as if a bow had dragged across a hidden string. The timing matched the expected arrival of a pressure pulse, launched many months earlier by a cluster of inner eruptions. The pitch implied an electron density higher than any measured in the heliosheath. The inference was plain: the craft was sensing the interstellar medium. Yet simplicity dissolved as the rings repeated. Months later, a new sweep rose slightly different in slope and strength, and between the sweeps the baseline drifted rather than remained constant. The interstellar medium itself was not perfectly quiet. It carried its own pressure variations and its own waves, and some of those waves were borne by shocks that did not originate in the sun but in the larger neighbourhood between the stars. The ear could not easily separate near and far history. Each event arrived as a layered message. A solar-borne pulse compressed the local gas, raised the density, and so raised the pitch, but the attributes of the rise depended on the state of the medium it entered. If the background was already compressed by a previous traveller, the new ring would start higher and climb less. If the background had relaxed, the same energy would produce a stronger swing. In some intervals the pitch lingered at interstellar values, while the magnetic field direction remained close to its heliospheric orientation, a mismatch that confirmed the porous and draped nature of the frontier. In others, the pitch stepped down toward sheath-like values for a while as a rarefaction passed only to recover without any corresponding dramatic rotation in the field. Through these episodes, the ear proved its power to turn time into a ruler. Each shock required a long journey to reach the probe, and by counting the months between the inner event and the outer response, engineers could estimate the average speed of the pulse through the sheath and beyond. The answer carried a spread that reflected the living texture of the path. In some seasons the pulse hurried, as if guided by tighter fields and warmer gas. In others it loitered as if the medium resisted. The cosmic ray counters also reacted to each arrival. Compression increased, scattering modestly steepening gradients and changing the mix of arrival directions, and then easing as the ring faded. In those moments, the sheath and the interstellar medium behaved like a bell tower, answering distant weather. The ringing did more than measure density. It revealed how stress travels through a boundary that is neither thin nor still. A pressure pulse can cross the heliopause without erasing it, like a tide that lifts both shorelines while still respecting the channel. The field strength rises on both sides, the electron density peaks on the outside, and the draped geometry tightens, making transport across lines briefly more difficult for low-energy particles, while leaving high-energy ones almost unbothered. The spacecraft hears the combined effect as a chorus, in which each section matters a higher pitch for density, a stiffer note in the field, a change in particle voices all out of phase by a little, because the message hands from one property to the next as the pulse passes. In rare cases, the ring includes a faint echo, a second rise that follows the first by weeks. Such doubles suggest that the shock separated into two fronts in transit, or that a reflection formed where the draped field met a change in flow downstream, or that reconnection event released stored tension with its own wave. The absence of a camera means that these interpretations remain cautious, but the pattern strengthens with repetition across years. The outside is a resonant body. Even when no obvious shock is on the way, the ear sometimes picks up very low-level waves that trace the ambient density, and those background tones drift slowly, arguing that the interstellar medium itself breathes on long time scales. Perhaps the sun moves through a patch of slightly thicker cloud, and the pitch creeps upward. Perhaps a remnant of a very old supernova passes and the pitch wobbles. Each drift feeds the lesson that the craft's outward progress is superposed on the medium's own weather, and that a single coordinate cannot capture what it means to be beyond. The subtlety reaches into operations. Because power wanes year by year, duty cycles must favour the ears that still bring new leverage. The plasma wave instrument consumes little, relative to what it returns in frontier knowledge, so it stays on for long intervals, and its low data rate can ride a weak link with ease. In return, the instrument gives navigation by physics a density derived from pitch, a distance inferred from the delay between inner events and outer responses, a context for every surprise in particle counts and field strength. The ringing also answers a deeper question that touches the theme of escape. It proves that interstellar space near the Sun is not a silent void, but a responsive medium coupled to the star by waves that carry information without carrying matter. The Sun can touch the outside across the heliopause not with a hand but with a tremor, and the outside replies in a language that the craft can understand. If escape were a clean break, the tremors would die at the border, and no interstellar pitch would echo the inner eruption. Instead, the border transmits, modulates, and remembers. The notion of outside therefore shifts once more from place to behaviour. Beyond is where density speaks in the higher register of the interstellar medium, where the magnetic field is stiffened by the larger neighbourhood, even when it remembers the Sun, where shocks from inside arrive as gentle bells rather than as shattering waves. Voyager finds that place and names it by listening, and in doing so learns that the dark is not mute. It carries news, it carries history, and it carries the ongoing conversation between a star and the thin gas that surrounds it, a conversation in which escape is only one verse. Cosmic rays approach the frontier as both messenger and test a rain of high-energy particles born in distant supernova remnants, and in older shocks that wander the galaxy, and their behaviour at the boundary tells whether the Sun's protective bubble functions as a wall, a membrane or a sieve whose mesh changes with time. Inside the heliosphere, the outward wind and the tangled solar magnetic field modulate this incoming rain. The flow scatters and slows the particles, lowers their number at lower energies, and imprints a seasonality linked to the cycle of solar activity. Farther out near the margin, where the wind thins and the field drapes the gradients in cosmic ray intensity, steepen, and a traveller can read those gradients like contour lines that trace the strength of the shield. Voyager carries counters that register the arrival of particles across a span of energies, and as it climbs through the sheath, the instruments watch two families trade places, the particles energized within the heliosphere itself, including those accelerated near the termination shock after beginning as neutral atoms that became ions, decline in number as the path nears the outside. The particles that belong to the galaxy at large grow in number, and their gradients begin to flatten as if the sieve has widened its openings for them. This switch does not occur in a single step. A compression launched from a solar eruption can temporarily harden the shield and steepen the gradients, and as the compression passes, the gradients ease again. In some cases, the counters record a rolling pattern, where the numbers rise, pause, and rise again, suggesting not one bound but several layers, wherein the ease of motion along magnetic lines differs from the ease of motion across those lines. Pitch angle distributions which tell the preferred directions of arrival relative to the local field sharpen or broaden as those lines tighten or slacken, and in that sharpening the instruments see the geometry inside the sieve. The problem can be phrased as a contest between two types of travel. Along the field, scattering is relatively weak and particles can stream with minimal hindrance, limited mainly by fluctuations that mirror and demirror them. Across the field, motion depends on a slower process in which small irregularities and large folds work together to nudge a particle from one line to the next. When the draped cloak at the heliopause lies smooth, a long field transport dominates, and galactic particles find channels that carry them inward, while lower energy heliospheric particles struggle to leave. When turbulence grows and reconnection stitches solar and interstellar lines cross field routes open, and the sharpness of gradients softens, the counters operating without a picture reconstruct this tapestry from statistics. On days when arrival directions become more isotropic and gradients shallow, the implication is that gates have opened somewhere upstream. On days when arrival directions favor motion along a single local direction and gradients steepen, the implication is that a mesh has tightened. The frontier responds to distant events even here. Forbush decreases temporary dips in cosmic ray intensity, caused by passing shocks, and their compressed magnetic fields still appear in the numbers muted and stretched by the long path, but recognizable as a traveling signature from within. Their presence beyond the heliopause confirms that the outside hears the inside through the language of magnetic pressure, and that the sieve can change its mesh on command from the sun. The energy of the particles sets an order on these negotiations. High-energy members of the galactic population with rigidities that keep their paths straighter penetrate more easily and see the boundary as a gentle gradient. Lower-energy members are diverted, mirrored, or delayed, and in their numbers the notion of a gate becomes most literal. In the same intervals where the electron density argues for interstellar conditions and the magnetic field direction changes only slowly, the high-energy count may already have plateaued, while the lower-energy count still climbs in steps. Such behavior makes the word beyond dependent on which voices one listens to. If beyond means a place where galactic particles at many energies travel without strong modulation, then the craft needs to traverse not only a density rise, but also a region where the draped field has lost enough solar weave that cross-field scattering no longer disfavors the lower energy group. The decline of the population born within the heliosphere adds another signal. As the traveller moves outward, the counts of these anomalous particles fade and their gradients steepen, in the sense that any small step outward produces a larger relative drop. This steepening announces a shrinking reservoir and a growing difficulty in returning along lines that now tend to favour outward motion or reconnection to the interstellar system. Yet even this decline can stutter when a compression arrives, because the passing ring briefly traps some of the remaining population and changes their pitch angles, creating a local respite that a naive reading might mistake for a structural feature. Through all of this, the magnetometer provides the scaffolding. Small rotations in the field suggest when the channels that favour a longline movement have shifted, and increases in field strength signal periods when mirroring becomes more effective for lower energy particles. The plasma wave ear, by following density, supplies the backdrop in which the particle play unfolds. In rare cases, the counters record sudden, nearly step-like changes that persist, as if a principal membrane has at last been crossed. These steps argue for a threshold in topology more than in chemistry, a place where lines that remain connected to the sun give way to lines that close on the interstellar medium and do not return. After such a step, the galactic counts level near values expected in the local interstellar spectrum, while the heliospheric population remains suppressed. Even then, the subsequent ringing from an inner shock can modulate the new baseline, proving that the membrane passes information, while blocking most of the flow of matter. The lesson that emerges is that particles write the frontier in their own script. Density alone cannot define escape, nor can magnetic direction alone, nor can a single rise in cosmic ray counts. Only the combination of flattened gradients, isotropic rival directions, persistent interstellar density, and a field that at last resigns its solar alignment can claim a durable outside, and even then the outside remains connected by waves. Voyager reads this script with care, and in the cosmic ray gate it discovers a parable that fits the whole mission. Freedom can grow step by step through channels that open in a moving geometry, and it can be modulated by voices from home that travel farther than expected. The craft proceeds, and the rain of high-energy particles keeps score, not simply announcing escape, but measuring how the meaning of escape changes with energy, with direction, and with time. Beyond the giant planets lies a dim architecture that does not end, where the wind of the sun grows thin, a realm of cold bodies and long-period travellers that extend the solar system's citizenship far past any breathable border. And the lesson waiting there is that belonging is written in gravity rather than in the texture of plasma. The Kuiper Belt, a torus of icy worlds beyond Neptune, fades outward into a scattered disk where objects follow stretched ellipses tilted and twisted by past encounters, and even this population, wide as it is, does not close the book. Far beyond, at distances that take light many months and then many years to cross the Oort, cloud is thought to surround the sun in a vast sphere of comets, a halo planted in the early days when the giant planets flung leftover bodies outward, faster than they could escape the star but far enough to be parked under the gentle custody of galactic tides. The cloud is an inference made strong by the rain of long-period comets that fall in from random directions, and although no telescope has yet resolved the crowd directly, the statistics of arrivals tell a consistent tale. A distant reservoir exists, loosely bound to the sun, waiting for nudges from passing stars and from the slow tilt of the galaxy's own field to send its members toward the inner worlds. Voyager travels within this far family, whether the heliospheric skin lies behind or ahead. The craft carries positive energy relative to the sun in the classical sense. It will not fall back, will not return on an ellipse, will not be captured by any planet. Yet the distinction between positive energy and membership is subtle. The Oort cloud's bodies remain bound, and their collective mass, though small, maintains a gravitational city that the star will carry along its galactic orbit for ages. Within that city, the craft is a fast pedestrian, not a resident, but the street it uses still belongs to the sun. Gravitational belonging answers to the hill, sphere the region around a star where its pull outweighs the tidal pull of the galaxy, and that region reaches far beyond the heliopause encompassing the cloud's outer shell. To leave the family in a strict sense would be to cross the limits of this sphere, and that transition lies so far away that no present machine can approach it. Meanwhile, the role of distant neighbours complicates the picture. A passing star within a few light years can tilt or stretch, the cloud changing the rate at which comets fall inward. A giant molecular cloud encountered over millions of years can stir the outer members and raise the number of visitors for a while. Galactic tides, the slow differential pull of the Milky Way act, continuously turning comet orbits like the hands of a patient clock. Through these influences, the sun's household extends to scales where interstellar and solar forces mix, and at those scales the idea of escape dissolves into overlapping jurisdictions. The Kuiper Belt and the scattered disk add a nearer echo of the same law. Their objects, many of them in resonant dances with Neptune, remember the early migrations of the planets when gravitational trades moved the giants toward and away from the sun, and scattered icy bodies across broad lanes. Voyager crossed the outer edge of this region long ago in distance, yet the resonant pattern lives in the statistics of small bodies it once photographed, and the drag of that history reaches the frontier as a reason that the system cannot be reduced to a wind bubble. Even if the plasma identity changes at the heliopause, the gravitational architecture remains an invisible truss that endures when winds and fields have breathed and changed many times. Reference frames reveal another tie. When mission plots show the craft racing outward at many kilometers per second, the speed is measured in the solar frame, a natural choice for heliophysics. When the galaxy becomes the frame, the Sun itself is moving at tens of kilometers per second around the Milky Way, and the Oort cloud rides with it as a defocused irregular sphere. In that wider context, the craft's path is a thin line, embedded in a broad, slow river, and the river carries the family along. The boundary where interstellar plasma becomes the local medium may be near in comparison, but the social boundary of gravity is far. Even the measurement of outside remembers this fact. When a distant shock raises electron density beyond the heliopause, when the field tightens under galactic pressure, when the cosmic ray rain flattens into a local spectrum, these changes all occur within a space that the Sun's mass still shapes for a very long time. The phrase solar system often hides this dual meaning. As a wind system, it ends near the heliopause, a membrane that leaks information but sorts matter. As a gravitational system, it persists to the cloud, then to the Hill sphere, and only beyond that does the Sun's rule yield to the galaxy. In one sense, Voyager left long ago. In another sense, it remains within a border drawn without material markers, a line that no instrument on board can detect directly, because it is an abstract ratio of forces. That invisibility recasts escape as a choice of what to measure. Plasma and field say one thing, comet statistics and tides say another. Both are true. The first declares that the craft now drinks interstellar electrons. The second insists that the star still holds a domain that the craft has not finished crossing. The argument is not a contradiction, but a layering. The solar system has multiple skins, one made of wind, one made of orbits, one made of long pale stones placed by tides over hundreds of millions of years. Voyager passes the first and senses the second, and will travel within the third for a span that dwarfs all mission plans. In that span, the giants will keep their moons, the cloud will shiver under distant flybys, and the faint rain of new comets will continue to prove that the household endures. The traveller's message read against this architecture is that escape can be true in one layer and premature in another, and that what seems beyond by air can still be within by gravity, a far family that does not end when the wind does. Escape sounds like a single act, a clean departure from one realm into another, yet the farther the traveller moves from the Sun, the more that word fractures into meanings that depend on what is being measured, which frame of reference is chosen, and which layer of the solar system counts as home. In the language of classical mechanics, to escape means to carry positive total energy with respect to the star, so that the path becomes an open curve, and distance can grow without bound. By that measure earned through carefully planned slingshots at the giant planets, the spacecraft succeeds. Its speed relative to the Sun exceeds the local escape speed and will not fall to zero. But in the language of fluids and fields, escape means to leave the domain where the solar wind sets the terms, and by that measure the claim arrives in stages because pressure density and topology do not switch all at once. In the language of gravity, as architecture, escape means to step beyond the outskirts of the Sun's household, past the faint spherical congregation of comets that builds the Oort cloud, and out beyond the Hill sphere where galactic tides win. That measure lies so far away that no present machine can reach it, and so the craft lives inside one sense of freedom while remaining a guest in another. Frames of reference bend the word further. Speeds quoted relative to the Sun tell the story of slingshots and open trajectories, yet the Sun itself races around the Milky Way at tens of kilometers per second. In the galactic frame, the craft rides a thin line drawn into a great river, and its absolute direction through the local interstellar medium depends on both its own motion and the star's drift through the surrounding cloud. A headwind felt by the heliosphere turns into a skewed current at the boundary, so that approach angles to the heliopause depend on a geometry that moves with the family. Escape from the wind bubble therefore looks different when measured in the solar frame than when measured in the frame of the surrounding gas and field, and the difference matters because particles and waves care about the frame in which fields are at rest. Topology adds another hinge to the meaning. A charged particle does not roam where it pleases. It follows magnetic lines sliding along them and crossing between them only slowly. A spacecraft that moves from a region where lines remain connected to the Sun into a region where lines close on the interstellar medium has crossed a deeper kind of border than one that registers a simple rise in density. In some intervals, the craft occupies a space with interstellar density, and yet remains threaded by draped lines that remember the Sun, a condition in which escape by chemistry has happened, while escape by topology is still negotiating. Only when gradients flatten, when arrival directions of galactic particles broaden, when field angles finally concede their long solar bias, does the case for topological escape gather its strongest footing, and even then the boundary transmits news in waves. The time dimension insists on a say. Escape from the wind cannot be final while the heliosphere keeps breathing. Pressure pulses launched under the Sun travel outward and tighten the mesh of the heliopause for a season, then pass and loosen it. Sector boundaries drift through the sheath and flip the polarity that organizes charged motion, without erasing the density that declares the outside. A traveller can be beyond in the morning by one measure, and slightly less beyond in the evening by another, not because the craft has turned, but because the edge is inhaled. The meaning of distance itself grows layered. A plotted radius from the Sun places the traveller farther and farther away, yet what distance to the heliopause means is a function of time, because the surface approaches and retreats on scales, comparable to the distance a craft covers in a season. The most cautious statement for escape in such a place is statistical a durable trend toward interstellar density. A sustained plateau in galactic particle counts a persistent weakening of heliospheric signatures, a slow rotation of the field toward the neighborhood beyond. Even at that plateau, gravity refuses to vacate the stage. The Oort cloud and the Hill sphere remain, and the star carries both along its long orbit like a family walking through a larger city. Escape from the wind is thus a passage within a household that persists. Momentum and energy define one freedom. Membership defines another. From the standpoint of navigation and engineering, the distinctions are not semantic. Power that declines with the decay of radioisotopes imposes its own notion of escape, a budgetary limit that closes doors. If an instrument must be switched off to save a heater, the ability to prove a finer meaning of beyond may fade. The deep space network gathers a signal that weakens with distance, until the cadence of returned bits sets the resolution with which borders can be drawn. The craft may have passed into the interstellar medium by several tests, but if the remaining senses cannot sample the plasma directly, or cannot time the ringing of a distant shock with enough precision, the best definition of escape is the one supported by what can still be heard. Philosophy and measurement meet in a quiet compromise. Escape becomes a verb rather than a noun. The craft escapes the supersonic wind at the termination shock. It escapes most of the heliospheric weather across the sheath by degrees. It escapes the crowded modulation of cosmic rays at a topological threshold where lines hand off allegiance. It escapes the star's direct control over its path the moment the last gravity assist leaves its energy positive. It does not escape the family of the Sun while comets still circle in the cloud that the star carries with it, and it does not escape the conversation with the sun while waves from inner eruptions continue to ring the medium beyond. To ask whether Voyager has escaped is to ask which book one is reading. In the Book of Mechanics, the answer is yes and old. In the Book of Plasma, the answer is a story with late chapters still arriving. In the Book of Gravity, the page has not yet turned. Voyager continues, and the word continues to evolve with it, proving that in a layered system, a single definition cannot hold all the ways that outside is written. Power fades like a long sunset across the spacecraft, and with every year the mission writes new rules for survival that are also rules for knowing, because the act of measurement depends on heat electricity and the strength of a whisper that must cross the darkness. The radioisotope thermoelectric generators convert the warmth of decaying material into electrical power, and that power declines steadily as the heat source weakens and as the thermocouples age. In the early decades, the margin is generous enough to run many instruments together, to warm valves, to steady clocks, to keep memories alive with comfortable voltage. Far beyond the giant planets, the budget tightens into a discipline where each watt is an argument. Engineers choose which heaters must glow and which can rest, which sensors may listen and which must sleep, which data can be compressed for return and which must be summarized to a few faithful numbers. A heater switched off makes a camera that once mapped clouds become a cold weight that steals nothing but radiates away the thin reserve. A spectrometer that once tasted starlight yields its wiring harness to silence so that a plasma ear may stay on because density in the dark now matters more than color. Triages like these do not happen once. They recur, and each recurrence changes the science as much as it changes the craft, because the remaining instruments reframe what the frontier can say. Cold imposes a second grammar, metal contracts lubricants thicken, and components that were tested for deep space still learn new habits, under temperatures they only visited in chambers. Baselines drift because calibration curves written near Earth never foresaw decades of frost. A magnetometer can still read a field line with elegance, but its offsets must be tracked against the slow creep of temperature. A particle counter still hears a rain of cosmic rays, but its electronics respond a little differently when the board lives in a colder night. The mission absorbs these changes with patience, building new calibrations out of crews, subtracting the instrument from the sky, until the remainder shows what the medium declares. Electricity rules attitude as well as knowledge. The spacecraft holds its high-gain antenna on Earth by small thruster firings that correct drift and keep the narrow beam aligned with dishes on the ground, and those firings consume propellant whose inventory cannot be refilled. The hydrazine stays liquid in lines that prefer to freeze, so a heater must keep the path above a threshold, and every hour of warmth paid into the plumbing is an hour stolen from another device. Pointing grows harder as distance grows because the beam narrows by geometry and the tolerance on attitude tightens. If a temperature change disturbs the balance, if a safe mode resets a gyroscope bias, if a small leak ever alters a valve's behavior, the next firing must compensate spending propellant that will never return. Each correction is successful until one day the ledger says no more, and so the plan is to waste nothing and to align every small act with the aim of hearing a little longer. Communication becomes the narrowest of bridges. In the days of the giant planets, the downlink carried images and spectra at rates that felt abundant. In the far reach, the link thins to a slow stream coached across space by the great antennas of the deep space network, stitched together by error corrections scheduled by shared time with other explorers that also need the sky. A command can take many hours to arrive and a reply takes many hours to return, so sequences must be written, like long poems that anticipate hours of silence rare chances for feedback, and the possibility that a single missed line will cause a page to be skipped. The bitstream itself becomes a scientific instrument because the pattern of frames and checksums their delays, and their occasional scars say something about the health of the bus, and the temperature of the radio, and the steadiness of the pointing. The art is to accept the smallness of the pipe and still extract a world of meaning through it. That art relies on changing how the craft listens. When power falls, duty cycles narrow into windows. A sensor that once watched continuously now samples for an hour, then rests for a day, then samples again, and the data become a series of careful snapshots that must be aligned with the pace of the frontier. A plasma wave receiver that hardly sips power stays on because its tones measure density beyond the heliopause, while a direct plasma cup may have long ago fallen quiet and must be replaced by inference. A cosmic ray counter stays alive because its trends announce the softening of modulation into the local spectrum. A magnetometer remains because field direction and strength still write the geometry that decides transport. Together, these survivors can still tell the story of a boundary that breathes even when the orchestra has lost many sections. Even austerity finds surprises. Cold can make a latching relay reluctant, and a command that should wake a circuit may need to be repeated with a different cadence. Radiation from a passing compression can flip a bit in memory and send the craft into a protective posture that saves the antenna alignment, but pauses the scientific ear, and the recovery costs fuel and time. Software written in an earlier century learns to live with contingencies that no one fully imagined, and still it adapts through careful patches and through strategies that reweight priorities toward the instruments that count most for the outer medium. There is also an economy of attention on Earth. The dishes that listen must divide their hours among many missions, and a weather front or a maintenance window can steal a pass that cannot be repeated for days. The craft stores what it can, then trims, then resumes, and the chain of meaning remains unbroken because the physics of the frontier is slow enough that gaps can be bridged by trends. In this fading fire, the meaning of escape takes a more human shape. Freedom in space is not the absence of ties. It is the capacity to go on while preserving the single bond that makes the journey more than motion, the bond that returns news to a small set of listening circles under a blue sky. The craft is free in energy and in path, but it is bound by the need to speak, and that need shapes every choice. To save a watt for the transmitter is to accept a colder instrument. To save a gram of propellant for a final attitude correction is to stop a heater that would have spared a sensor some strain. The paradox is gentle and absolute. A machine that has escaped by mechanics still depends on its origin to make that escape legible. The bitstream that narrows with distance becomes the tether that proves freedom. The heaters that blink on and off become the pulse by which the far medium is timed. The small firings that hold the beam on Earth become the strokes by which the boundary is drawn. The fading fire therefore does not argue for an end. It argues for a quieter form of continuation, in which each remaining instrument learns to say more with less, and in which escape is measured not only in kilometers, but in the persistence of a voice that keeps the conversation alive between a star its far bubble and the thin answering dark. The long arc of the sun through the galaxy sets a horizon for the traveller that no instrument can span, and within that horizon belonging widens from a wind and a cloud to tides, flybys, and slow changes that unfold over millions of years. The star circles the centre of the Milky Way in an orbit lasting about 200 million years, rising and falling across the galactic plane, while drifting through interstellar clouds of differing density and magnetic character, and each passage writes a new chapter in the boundary the spacecraft inhabits. Galactic tides, the gentle differential pull of the galaxy on the sun, and on the far members of the Oort, clouds slowly turn comet orbits and loosen outer bonds, sending a few stones inward while seating others in the halo. A close star, rare in one human span but expected across deep time, can tilt the cloud shake loose distant bodies and repaint the statistics of long-period comets that will fall toward the inner worlds. Against these rhythms, the spacecraft moves on a simple line, its energy with respect to the Sun positive, and its heading set by decisions near giant planets long ago, and that line does not return to the star. Yet the line is drawn within a moving frame. The Sun carries its far cloud along its way, the cloud feels tides and the shiver of passing stars, and the heliosphere breathes with the solar cycle and with the pressure of the local interstellar medium. In this frame, the probe is free and not free at once, free in mechanics, and limited by the society of forces that keep the family coherent as it travels through a larger city. Shock fronts from ancient supernova sweep through, at intervals raising pressure and stiffening magnetic fields, while cavities carved by former stellar winds open like basins. If the Sun enters a slightly denser region, the heliosphere can shrink and the heliopause can press inward. If the star slides into a clearer patch, the bubble can relax and swell. A craft that crossed the border under one weather might have crossed later or earlier under another. The lesson is that escape is not an absolute place, but a relation among moving things. Freedom becomes a vector rather than a point quoted relative to the Sun for path, relative to the medium for plasma, and relative to the galaxy for membership, and none of those references stand still. Over longer times, the Sun's own life will revise the stage. A main sequence star ages by changing its wind, its light, and the rhythm of its magnetic cycle, and those changes reach outward to retune the heliosphere's pressure and texture. The spacecraft will not know those seasons because power will fade and the voice will dim, but the path will continue through districts of the galaxy the builders could not name. Its trajectory was written by gravity assists that borrowed motion from worlds, and its logic was shaped by a need to speak across a growing distance to long ears on Earth. To imagine isolation is to forget the threads that still touch it through definition, if not through force. Galactic tides will not change its line yet. They will decide whether the region it flies through is full of slow comets or nearly empty. Stellar flybys will not bend its course, yet they will repave the sky. It crosses with streams of dust and with fields that lean at new angles. Future shocks born in places the craft will never learn about will still send waves that would alter how an instrument might have read density or field. Thus the machine proceeds under a rule that sounds like a paradox and proves to be a map. Autonomy is real, but context never vanishes. The solar system remains a household built of several skins, wind and field near the star-distant orbits in the halo, and a hill sphere that marks the outermost reach of the Sun against the tide of the galaxy. The traveller has left the first skin and will roam for ages within the others, and the street it uses belongs to a city that keeps moving. To say that the craft cannot truly escape is not to deny its triumph. It is to note that in a universe of nested systems, every track is traced on a larger moving page. Planets once gave the craft speed. That gift decided which corridor through the heliopause it would later cut. That corridor and its magnetic geometry decided how particles and waves would write the first definitions of outside. The definitions themselves will drift as the family drifts through new interstellar weather. So the narrative rests not with a gate left behind, but with a horizon that walks ahead. The spacecraft is free in the way a river is free following gravity across a landscape that also moves and forever bound in the way a river belongs to its watershed, carrying the memory of its source into the plain. It moves outward, the sun moves on the boundary, breathes, and the tides continue their patient work. And in that motion the word escape keeps its mystery, meaning at once departure relation, and return in the form of waves that still carry news from home. Night gathers around the idea and softens its edges, and the traveller becomes a quiet point moving through a fabric that moves as well. The breath of the heliosphere grows faint behind it. The interstellar medium hums with the gentle pitch that drifts, and the sun turns on its long road with the family in tow. The giant planets that once bent the path recede into memory, their gifts of speed folded into a line that no longer curls back, and the boundary that once seemed a cliff reveals itself as a seam that drapes and rings and lets news pass. Cosmic rays arrive with less modulation, magnetic lines lean from two histories at once, and the spacecraft listens as long as its small fires allow turning bits into meaning and then into a story that returns across a widening dark. Beyond the reach of heaters and relays, the way remains shaped by tides and by distant weather that changes slowly and never ends. Freedom holds, and so does relation, like a river that remembers its source even as it runs beyond sight. In that balance, the word escape loses its sharpness and becomes a soft curve, a path that leaves and still belongs a motion that measures not a door but a distance and a patience. One star keeps a moving household, one machine keeps a faithful course, and between them a conversation continues in small voices that cross the gulf with practiced care. Let the image settle, a faint signal on a great dish, a number that rises and then steadies, a field that turns by degrees, a wave that rings and fades. The universe makes room for all of these, and the mind follows them to a place where the clocks run slowly and the scales are kind. The craft is far and growing farther, the family is wide and grows wider, and both endure carrying each other in their definitions while the galaxy turns.